Dear students, in this video you will learn about methods of starting synchronous motors using pony motors, using damper winding as a slip ring induction motors. So, we have various methods of starting synchronous motors. First, synchronous motor is a not self starting motor. It is necessary to rotate the rotor at a speed very near to synchronous speed. That is what this motor is called synchronous motor. Synchronous speed means constant speed. Synchronous motor runs at synchronous speed, that is constant speed. So, this is possible by various methods in practice. So, using pony motors, using damper winding as a slip ring induction motor. One more method using small DC machine coupled to it. First method we will see using pony motors. So, in this method the rotor is brought to synchronous speed with the help of external device like a small induction motor. So, using the small induction motor, so we are taking the synchronous motor to synchronous speed. So, such an external device is called pony motor. So, external device induction motor, here we are using small induction motor, we are using to get the synchronous speed. That is what the small device is called pony motor. Once the rotor attains synchronous speed, the DC excitation to the rotor is switched on. Once rotor gets synchronous speed, then only DC excitation will be switched on in this type of method. Once synchronism is established, pony motor is decoupled. So, once synchronism is established in synchronous motor, this motor will be disconnected. Decoupled means disconnected. So, this motor will be removed from the connection. The motor continuously rotates at synchronous speed, then the motor is called synchronous motor. Okay. So, this is the one method of starting of synchronous motor, and so using damper windings. So, damper windings already we have discussed to eliminate the hunting in synchronous motor, which is also used to start the synchronous motor. So, damper winding is also used to start the synchronous motor. In a synchronous motor, in additional winding to the normal field winding, that additional winding is called damper winding. So, in this figure we can see damper winding, normal winding. So, F1 and F2 represents the normal winding, and damper winding is short circuited. Damper winding is not open circuited, damper winding is short circuited around normal field winding. So, the bars are short circuited with the help of end rings. So, the damper winding bars already short circuited end rings. Such additional winding on rotor is called damper winding. So, the additional winding what we are using in around the field winding, that winding is called damper winding. So, this winding is short circuited, acts as squirrel cage rotor, winding of an induction motor. The schematic representation of the such damper winding is shown in the figure. So, once the rotor is excited by 3-phase supply, the motor starts rotating as an induction motor at subsynchronous speed, that is not constant speed. The DC supply is given to the field winding. At a particular instant, motor gets pulled to the synchronism. So, synchronism starts rotated at synchronous speed. So, once normally we will give supply to the 3-phase supply, then rotor will starts rotates. So, that time synchronous motor runs at subsynchronous speed. So, once if we connect DC supply to the field winding at a particular instant. So, motor gets at synchronism. So, then motor rotates at synchronous speed. As rotor rotates at synchronous speed, the relative motion between the damper winding and rotating magnetic field is 0. Okay. Hence, when the motor is running synchronous motor, there cannot be an induced EMF in damper winding. Since damper windings are short circuited, there is no induced EMF in the damper winding. As damper winding is active only at start, to run the motor as an induction motor at start. Afterwards, it will be out of the circuit. Damper winding will be out of the circuit. The damper winding is short circuited and the motor gets started as induction motor. Okay, na? So, damper winding. So, one more use is to start the synchronous motor. So, and also we can prevent the huntings inside the synchronous motor. So, now we will discuss one more method of starting as a slip ring induction motor. So, the above method of synchronous motor is squirrel cage induction motor method. So, now we will see the slip ring induction motor method. To achieve this, instead of short circuiting the damper winding inside the synchronous motor, so here we have a external connection, external supply through slip rings, external connection, external rheostat we will connect. So, which is used to start the synchronous motor. Okay, external rheostat can be introduced in series with the rotor circuit. Already we have seen slip ring induction motor, how external resistance is connected. In similar way, here also we will use external resistance in this method. So, we will use to start the synchronous motor. Okay. So, the rotor resistance at the time of is connected high resistance. So, once motor starts, so gradually cut off. So, motor gathers a speed. When the motor attains the near to the synchronous speed, the DC excitation will be provided. So, DC excitation will be switched on to the rotor circuit. So, motor gets pulled into synchronism. Then the motor runs at synchronous speed. Okay. Now, we will see how the slip ring induction will be happen. So, here damper winding is short circuited. So, here we can see damper windings short circuited by short circuiting slip rings. So, slip rings we can see the initial resistance added in the rotor not only provided high starting torque, but also limit high inrush of starting current. Hence, it is acts as a motor resistance starter. The synchronous motor started by this method is called slip ring induction motor. So, here we can see here slip rings, how it is connected, how the external resistance is connected, how we are limiting the starting current. You can see in this diagram. Now, this is the last method, use small DC motors. So, many times as large synchronous motors are provided with a coupled with the DC machine. The DC machine is used as a DC motor to rotate the synchronous motor at a synchronous speed. Then excitation to the rotor is provided. So, synchronous speed it will rotate, DC motor will use to rotate the synchronous motor at synchronous speed, then excitation will be provided. So, once motor starts running as a synchronous motor, the same DC motor acts as a DC generator called exciter. So, without excitation, synchronous motor never runs at synchronous speed, that is what we need excitation. Okay. So, once a small DC motor also acts as a DC generator in this method. So, the DC generator will provide excitation to the synchronous motor. The field of synchronous motor is then excited by this exciter itself. So, DC generator itself will be excited. So, these are the methods we have to start the synchronous motor. Okay. So, we have damper winding method, small DC motor method, and slip ring induction motor method. So, these are the different methods we will use. So, we use to start the synchronous motor. So, next video you will see about universal motor and its applications. Thank you everyone.